Hey guys, this is Heatmaps here. Welcome to my channel. Today you will be learning a lot more about analytics platform. Okay, so this is I think one of my favorite platform that I use when I have to really understand the workflows. In data science world, a lot of the times when we start doing coding and running through all these different Jupyter notebooks or Python libraries, we forget what stages are we doing our projects on. A lot of the times we get lost. So I think having a analytics platform that can provide you a visualization and some sort of a workflow to make you understand step-by-step process on how to tackle data science project, I think you would definitely love this platform called KNIME. Okay, I've been using this for a long time, but I haven't really made a lot of videos on this, but I'm going to be starting to actually utilize this platform just to showcase, especially for the beginners who are coming into data science field, to understand how you can use this platform just to get an idea of how the steps are taking place whenever you are building your model. So remember, most of the time in data science world, you're looking at the data sets, and then you're visualizing it, you're understanding the data, you're pre-processing it, you're doing some transformation, then feeding into the model, you're running the models, fine-tuning the model, and then looking at the results, and those results are going to be useful for you to gain insights. So in this video, I'm going to be running through the whole process actually, but it is a very simple process. It's a simple linear regression model that I'll be building from scratch. I'll be showing you the data set and how I use some of the tools in KNIME to go through step-by-step process, and then ultimately get to the results and showcase how data science projects can use predictive analytics to predict some of the important factors that we are looking for. Okay, so let's get into this video. Okay, so here's the workflow that you will ultimately get when you have actually built the final, like the project. I am not going to go through from scratch and then bring in the tools. I have already built it, so I just don't want to make any changes to it. So I'll just go through the steps that I have taken. Okay, so in KNIME you have something called like the nodes that you can actually bring in. You can search through the nodes in a search bar. So if you go over here, like there is something called the node repository, so you can search for anything. Like if you want to do a CSV reader, you can just search for it, you'll get the CSV reader, you bring in that node, and then you apply it over here. Okay, so there are a lot of different nodes within the KNIME that you can use for data analytics purposes. Okay, so I'm not going to go through in detail. What I'm going to go through is just quickly go through the workflow itself. Okay, how I built this workflow and what all are the steps that I've taken in order to do this. So the first thing that you will do is obviously do a CSV reader. Okay, so when you do a CSV reader node evaluation, what you're going to get is a file location. Okay, so from where you are actually loading the file, and then also what it does is basically it gives you a good visualization of how it looks. Okay, so when you're looking at so I have a anime ratings data set. This is one of the sample data set that I'm working with, and I want to see what all are the information available in this. The KNIME platform actually provides a lot of this information in a useful format. So you can see that this is how the data set looks. It has some missing values. A lot of them are text, okay, in format, and some of them are integer. So you can see over here there's something called S indication, which shows that it's a string. I means it's an integer. Okay, and then D means it's a decimal or a float format. Okay, so that basically kind of gives you an indication of what type of data type it is, and it's useful to know because whenever you're going through your data cleaning process, you'll understand like what type of treatment that you're going to be doing for each of the columns. Okay, so in this case we are working with something called an anime rating. So we have a lot of different genres and different types of anime movies, such as Dragon Ball, Da Capo second season, WWE, Tayo Reborn. So these are different titles for different movies. Some of them are shown in TV, some of them are in web, some of them in DVD special. It tells you like what is the duration, what is the start date and end date. It tries to describe what type of anime movie it is. And then also it gives you an information in terms of the watch rates and the ratings that people have given you from, let's say, from IMDb or some other website, where the ratings are provided for these type of tools. And then also what kind of genre it belongs to, what type of studio it is, and whether the content there's a content warning in this or not. So these are the kind of information that we have in this data set. So how do we work with this? Now, first of all, you need to understand, what are your objectives, right? So in this case, our objective is basically to find out the ratings based on the title, based on the information that is given to us about the movie or a series or whatever it is, right? We need to find out what would be the possible rating that the consumers would give to this type of anime movies or different series, okay, the movie series or a TV series. So that is something that we want to find out. So that information is also available, like we have. So in this particular case, this becomes kind of like the analysis for supervised learning, because in this case we already know what type of rating is provided to all of these different anime titles. Okay, so the rating is already available to us. What we need to do is we need to build a model so that it can actually use the other information in order to predict what could be the rating for the new anime that might come up. Okay, so that is what this particular workflow model or the analytics model will going to do. Okay, so in order to go forward, what we're going to do is we're going to read this file. So in order to read this file, what we're going to do is just right click on it and then execute. So when you execute, it basically gives you this green button. That means it has executed. So the node has basically read the CSV file. Okay, so now we have read the CSV file. Let's go to the next stage. Next stage is duplicate row filter. So we need to figure out if there is any kind of duplicate information in the data set. So what this particular node repository does is that it looks at all the different types of columns and figures out if there is any duplicate value that we need to get rid of, because we don't want any duplicate information in our model, whenever we are trying to predict. So it looks at it, it gives you the information. This is a manual process of actually looking at all the rows that are included to figure out whether there is a duplicate value. We'll remove the duplicate value. Row chosen in case of duplicate, the first one, right? If we have 2 or 3 duplicate values, the first one will be chosen. Okay. There are other options that I'm not going to go through, because this is probably like a simple version of what I'm showing, like how to use this tool. So you have wildcards, you have regex, you have type. So I'm not going to go through all of that. Okay. The next thing is, treat any of the missing values. So if you, let's say, have some missing values in your data set, how do you treat them? So let's say in string, if you have missing values, what are you going to do? You're going to put a fixed value. Are you making a more frequent value, next value, previous value, remove row? So all of these are the options. So in this case, anywhere there is a missing value for string, we put it as unknown. Okay, instead of having a question mark or an NaN value, let's put it as unknown. Okay, for integer and duplicate, we are not doing anything right now. For float or double integer values, we're not doing anything right now. So let's keep it as it is. Okay, and then run this node. Okay, before that I'll have to run this as well. So let's run this. So it's done. Okay, and then I'm gonna run this, and this is also done. Okay, so once it is done, the output of the data set, what we can do is we can do something called a exploratory data analysis. We can visualize the data. We can see how things look like in our data. Now get a bit of an understanding on what information is out there. So we do something called an exploratory data analysis. So in this case, we will use something called a histogram. we'll use the votes as a dimension, or probably like, let's say, the y variable, which is our rating. That is what we're going to be using it. So let's say we'll use that. We'll execute it. We'll see how the histogram looks like. So this is how the rating distribution looks like in our data set. Okay, it's a very it's a normal distribution curve. It looks pretty good, and we should be happy with that. Now there are a lot of options here that we can work with. I'm not going to go through in detail each one of them, but you can actually again do a upper bound, lower bound, integer cutoffs, all of that stuff, but I'm not going to go into the details. Okay. So that's the distribution. We will look at the box plot. Okay, box plot is another tool that can be used in order to see how things look. So these are, it automatically picks up all of the values that are possibly in integer format, integer or float format. So it picks up those and then creates a box plot. So I'm gonna just run this. So when you run this, you'll see that EPS values are from it's a very small value, right? Duration is also, the magnitude of that value is pretty small. Start year, end year, again they're 2016 to 2000 probably 18, 19. So a lot of those values you can see over here. What is the max, what is the min? So the min is 1977 and the max is 2020. So you can actually hover over the bar chart and see what is the max and min, okay, value for start year and finish year. Watch time, again the value varies a lot. Okay, so in terms of magnitude, the watching, the value varies again a lot from 0 to 99. Rating, again rating is from 0 to 5. So that is what we are trying to predict. And then the votes the minimum is 10, the maximum is 3100. So that changes a lot too. So those are like some of these important, like again box plot that you can plot in order to see, visualize how your data set looks. The other thing you can do is create a bar plot, and once I double click on this, you can see that there is the category dimension. You have to choose what category dimension that you're working with. There are a lot of different types of category dimensions that you can use. Obviously they are in the text format. So let's say I'm looking at the media type, right? Media type, and I want to see how many occurrences does the media type has in the data set. So I'll choose the occurrence and then just plot. And then you will see that for each of the media type, let's say for TV, you have the highest occurrences. Okay, the media type occurrences is much higher in our data set, followed by movie, followed by OVA, and then web. So all of these values are already present in the data set. Okay, so those are possibly some of the things that you want to check, okay, just to visualize and see how your data set looks. And then you can also do something called a heat map. Okay, the heat map also provides you some sort of a correlation analysis to see like how your data would look. So in this case, you can see like a media type or a genre and see what is the the average rating values, plot, title, all of that stuff, right? Interactivity, image generation. So these are the things these are possibly called the exploratory data analysis. So these are something that you will be doing it on a day-to-day basis, okay, just to visualize and see what kind of relationship are we getting. So from genre to media type, what kind of overlap do we have in terms of, again, the average rating over here. So this provides like kind of a heat map to understand like how these two are correlated with each other. Okay, so you can do a lot of those exploratory analysis to understand your data pretty well. So once you have done all of that stuff, what you're going to do is you're going to do something called the preprocessing. So in preprocessing, there are certain things that you would want to do. Let's say you want to do some manipulation, you want to make some changes in the data set, right? So in this case, what we are doing is we have something called a finish year and a start year, okay? And what we want to do is we want to see how many years that episode or that movie was running in the in the year, or was it live, okay, where people were actually going out and looking at it, or probably they were available on the web. So we have the finish year, we have the start year. So the finish year, start year in itself will not provide any useful information, but when we actually see the difference between them, the years running, that might provide a good information. So we actually create this formula to get to that value. So we apply, and then what we do is we run, okay, so and then we execute. So what happens is that it creates a new output variable. So if you go down over here, so I can actually go and look at the output data over here, you will see that there will be a new column that is going to be created called the years running, okay. So the years running would be the one that will have the value 0, 1, or it can vary from again 0 to any value, so 0, 3, 5, 1. So this will be a good predictor for us to figure out what the rating might be based on the years running, right? So that's a new variable that we just created, okay. So that's it's again in the pre-processing state. You can do a lot of different variable creation, but this is probably one of the simplest one. The other thing that we can do is we can do something called a column filter, okay. In column filter, we can see like what all different columns that we don't need in our data set when we are doing some sort of a regression modeling or any kind of algorithmic modeling. So in this case, title and descriptions are not really relevant right now. We are not doing any text and analytics, so we don't have much say on like how to get useful information out of these two columns. So we'll remove them, okay. So this is basically again removing them and taking all the other ones. And then once we have done that, what we're going to do is we're going to execute it, and then it's going to basically run it, and then we have something called one-to-many. So one-to-many is actually something called it's basically used for creating dummy variables. So let's say you have different categories, right, for each of the variables. For media type, we had different categories like TV, we had OVAs, we have a web, we have a lot of these different media types. So you won't be able to use that information directly in your model. The model will only read zeros and ones or a numeric value, because it won't understand what you're talking about in terms of the category. So what it does, this one-to-many, what it does is it takes these string values, okay, it creates dummy variable automatically based on the number of categories that we have. So you just have to define like what all different string columns that you're choosing, and then hit apply. So once you hit apply, okay, and then you run this, okay, you'll see the magic here. This is amazing that it does that automatically for us, and it's done. And then you look at the processed data. So what happens is that you can see that over here, the studio type, there are a lot of different studio types here. A lot of them fall into others, but you can see that there are different studio types. You have genres, different genres, right, like whether it's a comedy or adventure, all of that stuff. Now you can see that there are so many zeros and ones columns that is being created. Now what has happened is that for each of those genres, for each of these media type, for each of these studio type, it has created a new column, okay, new columns like let's say for the movie media type, it has created, if there is a movie media type, it'll give value zeros or it will give value ones, okay. If it is a TV special, it'll give you value of 1, otherwise it's all 0. Okay, same way it will go through all of these different types of variable and create these dummy variables. Okay, this is what we're going to be using it on our data set. Okay, so once it is done, okay, what happens is that the output is going to go into the next stage, which is called the model build. You can now also do something called like a box plot analysis. This is something that I did in order to just check like whether the output data looks pretty good or not. So you can actually create like a box plot for all the variables that you have just created, and it basically gives you an idea of how these new values that are being generated, right? There are a lot of different types of values that is being generated. It just checks the values like how it looks. Okay, so a lot of that stuff is being created. I'm not going to go into the details, but that's what it means. The other thing is, again, we do partitioning. Okay, partitioning of data set from test and train. Okay, so when you look at this, obviously whenever you're building a model, you have to do partitioning. So when you have to split the data into train and test. So in this case, partitioning allows us to do that. Either you can do absolute or relative, or you can do randomly, or stratified sampling, or linear sampling and all that stuff, right? So in this case, we are doing a 70-30 split. So on training data set, we'll have 70% of the data, and then the rest of them are 30. Okay, and then it's drawn randomly. So once we do that, we run this, we execute it. Okay, so once it executes, you can see the green light, so that means it has already created it. So the training data set, which is again the first partition, you can see it on the first row. You will see that if you hover over that sign, you can see that rows is close to like 4,500. Okay, so that's almost 70% of the data. That is going into something called the linear regression learner. Okay, so linear regression learner will have all these values that we are trying to select for our prediction. Okay, so in this case, what happens is that you have to select what is your target variable. In our case, it's rating. Okay, and then the dependent variable, or sorry, the independent variable, or the predictors or the features, we need to select ourselves. A lot of them you do not need, like some of those features or predictors you do not need in your data set, because they are not giving a lot of information. So in this case, I have selected only the ones that will provide us a useful information in our regression model. Now, I haven't gone through the step-by-step process of how I have selected these variables, but there is another video that I can actually create in order to tell you guys that. But ultimately, these are the variables that came into the model, okay? And these are the variables that I have selected. So these probably will act as predictor, okay, for predicting the rating value. Okay, and then the rest of the stuff, you don't have to make any changes to it. Regression properties, keep it as it is. Missing value in the input data set, just ignore rows with missing values. Okay, and then hit apply. Okay, and then execute. So this gets executed, and then once you execute the data, you can actually look at the result. So in this case, this is how the linear regression results looks like. So I can make it a little bit larger so that you can see it. So these are the variables that basically came into the model with the p-value less than 0.05, which is like 95% confident that these values are making a significant impact onto the dependent variable, which is y. And the r-square that we are getting is 0.62, around 0.63 or 0.62. Okay, so this is not a bad model, means it can be improved, but right now we are getting around 0.62 as the r-square and the adjusted r-square. So this is probably this is what you're going to get at the end of the day. These are the variables that are making an impact in terms of predicting the ratings. Okay, so once that is done, what you do is you test this out in the regression predictor and see how it functions. So in this case, we're going to be running this model. There is nothing else that you have to choose here. I think you just have to run this model and see how it behaves. So once you execute that, what happens is that it looks at the test data set, it looks at the training data set, it looks at all the model, and then what it does is it creates this predicted data. Okay, so the predicted data, what it does is, like, whatever the model that you ran, right, it had the equation that has been built in, and ultimately what happens is that it creates this ultimate column called the predictor rating column. Okay, so that predictor rating column will provide you the prediction of the model based on all the input variables that we gave, right? This is not the actual value, this is the predicted value. So what happens is that if our r-square is 0.62, that means it is okay, that's not that great of a model. We want to check how how close are we with the rating that has been provided in the data set versus how our model is doing in the predicted value. So for that, we can just run just a diagnostic check called the scatter plot, and once you run the scatter plot, you will see the difference between your predicted value versus the actual value. So if you double click on this and see your Yeah, so this is what it looks like. So this is the final output that you're going to see. So basically what happens is that this is the actual rating on the x-axis, and the y-axis is the prediction rating. Okay, so this particular model basically tells you that you know, it's a linear regression model, right? So most of the values that you're going to be seeing is on the prediction side, is trying to evaluate like how close they are on the rating side. So with the R-square of 0.62, this is how it looks. Okay, so you can see that a lot of the values that is predicted as 2.3, they all fall from like, you know, 1.2 to almost 3. So possibly there are some issues over here that it's not able to predict like a very low rating series, okay, observations. So you know, something that we need to again fix. Probably there are certain things that we can use in order to really get this model with the better R-square. But you can see that again, there's a, you know, obviously as the rating increases, actual rating increases, the predicted rating also increases. So the accuracy isn't that great, but this is like kind of just a scatter plot to just see like how our model is behaving. Okay, so that would be the end of it. Again, so you have already built a model where actually you can predict you know, the ratings based on the data set that is given to you, and all the steps that you took in order to do that, right? From going from reading the value, reading the CSV, removing the duplicate values, taking the missing values out, you know, doing some exploratory data analysis, doing pre-processing, and then doing the model build. Okay, all of that in the same workflow, so you can actually visualize it and see how it looks. Okay, so that's about it. Hopefully you like it. If you guys need more information on KNIME platform itself, hit me up or put a comment below. Okay, thank you.